There might be a shortcut through the universe, a tunnel that lets you cross billions of light years in an instant. Physicists have a name for it, a wormhole. And here's the unsettling part. Nobody has ever seen one, but nobody can prove it's impossible either. Today on The Cosmic Vault, we're separating the real physics from the science fiction. Because what wormholes actually are is stranger and more fragile than any movie has shown you. Let's start with what a wormhole actually is. In 1935, Albert Einstein and physicist Nathan Rosen were studying the equations of general relativity when they found something unexpected. Their math allowed for a bridge connecting two separate regions of space-time, not through normal space, but through a shortcut folded underneath it. Today, we call this an Einstein-Rosen bridge. The term wormhole itself came later, coined in 1957 by physicist John Wheeler, comparing it to a tunnel a worm might bore through an apple, connecting 2 points on the surface without crossing the distance between them. The idea is elegant. Imagine folding a piece of paper in half with 2 points marked on opposite ends. Normally, to travel between them, you'd have to cross the entire sheet. But if you punch a hole straight through the folded paper, connecting the 2 points directly, you've created a shortcut. That's essentially what a wormhole would do to space itself. Here's the part most people don't realize. Wormholes are not some fringe idea. They are a mathematically valid solution to Einstein's field equations. The same equations that predicted black holes, gravitational waves, and the bending of light, all of which have since been confirmed by observation. Wormholes belong to that same family of predictions. The math works. The problem is everything else. For a wormhole to actually exist as a stable, usable tunnel, it would need to be held open against the crushing force of gravity trying to collapse it. And to do that, physicists calculate you would need something called exotic matter, matter with negative energy density. This isn't matter that simply repels gravity like antimatter does with charge. It's a form of energy that, as far as we know, doesn't exist in any large, stable quantity anywhere in the observable universe. There is one real, laboratory-confirmed phenomenon that comes close: the Casimir effect, where two uncharged metal plates placed extremely close together in a vacuum experience a measurable negative energy density between them due to quantum fluctuations. It's real, and it's been measured. But the amount of negative energy involved is astronomically smaller than what would be needed to hold open a wormhole large enough for anything to pass through. So if wormholes are mathematically real, but require something we've never observed in usable quantities, where does that leave us? It leaves us with one of the most fascinating, unresolved questions in modern physics. Some theorists have proposed that certain black holes might not be simple dead ends, but rather one mouth of a wormhole, with the other end opening somewhere else entirely, another point in our universe, or even, speculatively, another universe altogether. But even here, there's a catch. Most calculations show these wormholes would be violently unstable. The moment anything, even a single photon of light, tried to pass through, the added energy could cause the tunnel to collapse or snap shut instantly. This is why physicist Kip Thorne, one of the leading researchers on traversable wormhole theory, has spent decades studying exactly what it would take to keep one open long enough to be useful. Now here's where it gets even stranger. If a wormhole could somehow be stabilized, physics doesn't just allow it to connect 2 points in space, it could theoretically connect 2 points in time. By accelerating one end of a wormhole to near light speed, or placing it near a massive gravitational source, time would pass differently at each end, according to Einstein's relativity. In principle, stepping through could mean stepping into the past. This idea troubled Stephen Hawking so much that he proposed something called the chronology protection conjecture. The idea that the laws of physics themselves might conspire to prevent time travel paradoxes from ever occurring. Whether through quantum radiation feedback destroying the wormhole the instant it became usable for time travel, or some deeper law we haven't discovered yet. It remains an unproven idea, but a serious one, discussed in real physics papers, not just science fiction. And then there's the newest, strangest twist in this story. In recent years, physicists including Juan Maldacena and Leonard Susskind proposed a startling conjecture known as ER equals EPR. The idea that wormholes and quantum entanglement might be two descriptions of the exact same underlying phenomenon. In 2022, researchers at Caltech and Google Quantum AI used a quantum processor to simulate a simplified, toy model version of a traversable wormhole using entangled qubits, published in the journal Nature. It's important to be precise here. This was not an actual wormhole opened in space. It was a small-scale quantum simulation testing whether entanglement behaves the way wormhole theory predicts. But the fact that this experiment could be attempted at all shows just how seriously mainstream physics now takes the connection between wormholes and quantum information. So, do wormholes actually exist? The honest, unglamorous answer is, we don't know. They are allowed by the same equations that have correctly predicted black holes and gravitational waves. But every serious calculation of a real, traversable wormhole runs into the same wall. The need for exotic matter we've never confirmed exists in any usable quantity. Until that changes, wormholes remain one of the most legitimate, most tantalizing maybes in all of physics. That's the real story. Not a movie plot, but genuine open territory at the edge of what physics can currently explain. If this kind of mystery pulls you in, hit subscribe. That's genuinely the only way you won't miss what's coming next. This has been the Cosmic Vault, and I'll see you in the next one.